Right, telemetrics. Just having a look at the Andrews paper. We started, and let me just share the screen. Okay, so we're up to question 5, so we're just doing question 6. Okay, differentiation. So in this question over here, we've got y is equal to x squared minus 2 over root x, and we've got to determine dy dx. So remember the key idea here. Remember, if you've got something like 7 plus 14 over 6, you could normally you got 21 over 7, which is 3, but you could also say that that's 7 over 7 plus 14 over 7, which will be 1 plus 2, which is equal to 3. Okay, so here we're going to rewrite this as y is equal to x squared over root x minus 2 over root x. Okay, but then remember, root x is the same thing. Root x is equal to x to the half. So you get y is equal to x squared over x to the half minus 2 over x to the half. Okay, and then you go y is equal to, you got 2 minus a half. 2 minus a half is 3 over 2. Okay, so you get y is equal to x to the 3 over 2 minus 2 x to the negative half. So the variables always have to be, two things have to happen before you differentiate. You've got to get rid of surds, okay, using that logic, using the formula x to the m root n is x to the m over n, okay, and you cannot have variables in the denominator. And now we're in a form that we can differentiate, okay, and so we go y is equal to 3 over 2 times 1 is 3 over 2, x 3 over 2 minus 1 is going to be a half. So I get y is equal to 3 over 2, x to the half, plus negative a half times negative 2 is 2, x to the minus 3 over 2. Okay, the question didn't say leave your answer with positive exponents, it just said differentiate. Okay, so at that point over there, let me just check that I'm making any stupid mistakes. Okay, we're going to leave it at that, and we are dead right. Okay, sorry. I was being an idiot. Negative half times negative 2 is 1. So it's going to be x to the negative 3 over 2. If they said to you, leave it with positive exponents, okay, and you only have to do this if they specify that, you get 3 over 2 x to the half plus x plus 1 over x to the 3 over 2. Okay, but as I say, you'd stop over there unless they say leave with positive exponents. Okay, right. The next one. If I've got root y is equal to x squared minus 2, before you can differentiate, okay, you've got to make y the subject of the formula. So what you're going to have to do over here, okay, is go square both sides of the equation. So you're going to have root y squared is equal to x squared minus 2 all squared. And if you square that out, you get y is equal to x to the 4 times them together times by 2 minus 4x squared plus 4. So therefore dy dx is equal to 4 x cubed minus 8x, and that's it, 4x cubed minus 8x. Okay, so always make sure you get y on its own. Right, two little bonus questions. If I said y is equal to x squared minus 6x plus 8 over 2x minus 4, okay, well here, unlike in this case over in this one over here, where there was a single term, when there's a single term in the denominator, you can divide out. But if there's more than one term in the denominator, what you're going to have to do is factorize, and they must, at this stage of your life, have to cancel in order to then differentiate. So you factorize, cancel, differentiate. So over here, we factorize this, it's going to factorize to x minus 4, x minus 2. And if we take out 2 from the denominator, I get 2x minus 2. Now, because differentiation is a limit, we can cancel and then do the process. So the x minus 2's cancel. So we're left with y is equal to x minus 4 over 2. In other words, y is equal to a half x, just dividing out, minus 2. And if I go differentiate now, I should, by the way, say over here, x cannot be equal to 2. Okay, because of that. And if I differentiate now, I get y dash or dy dx, or the derivative of half x is just a half. Okay. Just one thing, if I had here y is equal to, I don't know, let's look at simple one, 3x plus 2. If I said, what is dx dy, dx, well, that would just be 3, that's straightforward. But if I said to you, what's dx dy, that means you're going to differentiate x in terms of y. So what you'd have to do first is get x on its own. So you get y minus 2 is equal to 3x. Divide by 3, you get y over 3 minus 2 over 3 is equal to x. And now I can differentiate. But now I'm differentiating x in terms of y, and that'll be equal to a third. Okay. So just be careful of that. If you see that notation, just whatever's at the top, you have to isolate it. If they want dy dx, you've got to get y on their own. If they want dx dy, you've got to get x on its own before you differentiate. Okay, that's question 6. Right, question 7 quickly. Right, common type of question. Okay, you're asked to find the equation of a cubic, okay, and you're given the turning point. Now, by telling you that's the turning point, and you've got to go find A and B, which generally means that you're going to have to get 2 equations and solve them simultaneously. So how can I get 2 equations from this? Well, first of all, okay, because 1, 4 is a turning point, at x is equal to 1, remember, at a turning point, the gradient is 0. So at x is equal to 1, okay, we know that the gradient is 0. In other words, f dashed of 1, that means the derivative at x is equal to 1, is equal to 0. So that's going to be the basis where I can get 1 equation. And I would always do that one first, because sometimes when you differentiate, you eliminate a variable. So before I can find f dashed of 1, I've got to find f dashed of x. So f dashed of x, I differentiate this over here, I'm going to get 3ax squared minus 12x plus 9, and the b falls away because it's a constant. Okay? But now we're going to use the fact that f dashed of 1 is equal to 0. So I sub in 1 into my derivative equation. So I get 3a times 1 squared minus 12 times 1 plus 9. So when x is equal to 1, the gradient must be 0. Okay? And if I simplify that, I get 3a minus 12 plus 9 is equal to 0. So 3a is equal to minus 12 plus 9 is minus 3. Move it to the side, I get 3a is equal to 3. So therefore, a is equal to 1. All right? Okay, so I've got a is equal to 1, but I've got to find a and b. But 1, 4 is a point. Now we choose the fact that it's a point. Okay? In other words, if I sub in x is equal to 1, I'll get a y coordinate of 4. In other words, we know that f of 1 is equal to 4. So if I sub 1 into the original equation, I'll get an answer of 4. So we also know a is 1, so I can replace that a with 1. So I'm going to get x cubed, that x is 1, so it's going to be 1 cubed minus 6 times 1 squared plus 9 plus b must be equal to 4. So I get 1 minus 6 plus 9 plus b is equal to 4. So therefore b is going to be equal to, well, 10 minus 6 is 4. Okay, so you end up with b is equal to 0. Yep. Okay, so b is equal to 0. And that's the question answered. The question was find. That was the question over there. If the point 1, 4 is a turning point in the graph defined by f of x is ax cubed minus 6x squared plus 9x plus b, determine the value of a and b. Right, so we've got a and b done. Right, the next question says, and the last one we're doing on this little video, is determine the equation of a tangent to f of x is equal to negative x cubed plus 2x squared plus 9x minus 7 at the point where x is equal to 2. Okay, so to find the equation of a tangent, I don't know what this curve looks like, whatever. It's something, who knows what it looks like, but we want to find the equation of the tangent at x is equal to 2. So to find the equation of a tangent, first I need, let's just say it was here, my graph could be completely wrong, okay, but I'm trying to find the equation of a tangent. What's a tangent? It's a straight line. So I'm going to end up, I've got to find m and c, and the formula y is equal to mx plus c. Right, so to do that, first of all, I need a point on that tangent. And we know that the point of contact happens at x is equal to 2. And it shares, that's the only point where it touches the curve around 2. So I've got to find the y value that goes with it, because that's a common point. So when x is equal to 2, Okay, in other words, y is going to be f of 2. In other words, y is going to be equal to negative 2 cubed plus 2 times 2 squared plus 9 times 2 minus 27. So you're going to get y is equal to negative 8 plus 8 plus 18 minus 27. So y is going to be 18 minus 27 is equal to, let's double check that I make a stupid mistake, negative 9. Okay. So 18 minus 27 is equal to negative 9. So your point of contact, my diagram's wrong, is 2, negative 9. Okay, so now I've got a point on this curve, and then I need the gradient. Okay, so now I'm looking for m. So the gradient, when x is equal to 2, the gradient is going to be equal to f dashed of 2. Okay, so I need to find f dash of x first. So f dash x is going to be negative 3x squared, if I differentiate this, negative 3x squared plus 4x plus 9. Okay, that's f dash of x. And now, when x is equal to 2, f dash of 2 is going to be negative 3 times 2 squared plus 4 times 2 plus 9, which is negative 12 plus 8 plus 9, and 17 minus 12 is 5. Okay, so the gradient is equal to 5. So now we've got a line where the gradient is 5 and we know a point, and that's enough. So you always got 2 steps to find the equation of a tangent. Find the point of contact and find the gradient at that point by subbing into the derivative. To find the point, you sub into the original. So now if I'm using y is equal to mx plus c, we know that m is 5, so y is equal to 5x plus c. And we know point of contact. The point of contact was 2, negative 9. So if I sub in 2, negative 9, I get negative 9 is equal to 5 times 2 plus c. So that's 10. So I get negative 19 is equal to c. So I end up with the equation y is equal to 5x minus 19. Okay, that's 6 and 7 done.